Yes, now I'm ready. Um, what I need now is for everybody to make sure they have that thing loaded up. And did I see? Um, so again, I want to address James's concern. There was one question I think he wanted to take a look at from yesterday, and I appreciate that. So let's take a look at this. What number were you talking about on this page right here? All right, now I tried to explain yesterday. That means P is between -4 and 4. That's what that means. And a hard bracket. Amazing. Math help, right?
Yeah.
Okay.
Wait, what?
Go. Tell me.
So much 14.
14. Here we go. Now, right. I'm really not too concerned here. A number -1 is at most 9, or 2 times the number is at least 24. Now again, the reason why this is a good problem right here is, now look, 13 you can kind of cross out. I don't want you concentrating on that. But 14 I thought was a fair question. All right. Now, again, the reason why I'm saying that is at most, right? And I always try to say if you have at most $10 in your pocket, that means it has to be what? Less than or equal to. Does everybody agree? And then if I have at least $24 in my pocket, that means I have more than or equal to 24. All right? So who asked me? Is that good now?
Yeah.
And then you're just solving it.
Oh, so when it says at least 24,
I just said, if I have at least $24 in my pocket, what does that mean? Yes. So this means greater than or equal to 24.
Oh, okay. Well,
right?
24 is on the other side, so 2 is greater.
Do you understand what I have on there?
Yeah.
Right? And n-1 at most, sometimes kids think most means greater than. Right? And
Yeah.
sometimes they say at least they think is less than because they see the word least. It's not the way it is. All right? And I say think in terms of money and make a situation up for that. If I have at most $9 in my pocket, right? Anybody else? What?
Number 11.
Let's take a look at 11. 11 is good. All right, so for number 11, all right, you're solving it like a regular equation, except there just happens to be 2 constants on either side of the variable, correct? So all we're doing is subtracting 2 from both sides, and then you're just dividing by 3. So again, take a look. Up here is where I started, and then I carried on right down here, all right? Any questions or concerns? And one more. Somebody said number 12. All right. Now again, we practice our mental math on that. 2c is greater than -2. Divide by 2, c is greater than -1. Subtract 1 and divide by 3, c is less than 4. You with me?
Yeah.
And it's an and statement. You read the problem and you see where it says and?
Yeah.
That's how I knew it was an and statement.
No, I don't know how.
What? It says and. You said you didn't know how it was an and statement.
No, that's not what I meant. It's and you combine them. It's or it's two. Oh.
You should be the teacher. All right. You're not the only person who thinks that. Go.
Was number, I see what you put for number 10. Did we, that was my first 10.
Okay, yeah. So now I put on this. This is only for the advanced. All right, so those guys who want to be advanced, you can kind of take a look at this. All right. So again, listen carefully, please. Listen carefully. All right, and I do think this is kind of important. All right, so thank you for asking about this one. All right, so again, we'll just start from scratch here. If I solve this, all right, this would be n is greater than -2, correct?
Yeah.
So greater than -2 would require open circle going to the right.
Yeah.
Now I think everybody can add 3 and make that 8 and divide by 2 and make it what? 4. So the other equation worked out to be n is greater than 4. So greater than 4. So now we have a problem, CC. We have a problem because this or statement is not going in opposite directions. All right? So most of the time the or statements will be going in opposite directions. But in this case, they're going in the same direction. So I tried to explain yesterday that an or statement means it has to be true for one or the other. Or it could be true for what? For both of them. That's an or statement. An and statement means they have to be true for what? Both statements. So because this is an or statement, please watch. If I'm greater than and greater than, that's where they overlap. So the question is, what's the answer? Because I kind of have 3 graphs there. All right? So now, here's how you answer that question. Listen carefully. I have this part of the number line. Do any of those numbers satisfy any of the inequalities?
No.
No. All right? Now, do these numbers here satisfy both inequalities? No. Do they satisfy one?
Yeah.
So is that a solution? Yes. Because we said it was an or statement. It doesn't have to be true for both. It only has to be true for what? One. All right. Now, this over here. Those solution or those solutions satisfy both inequalities. So are they part of the answer?
Yeah.
Yes. So that is why the answer to this problem is anything greater than -2. That's the answer. All right? Anything greater than -2. Now, I'm going to change it. All right? I'm going to change the or. Now, instead of being or, I'm going to change it to a what? And. So an and statement means it would have to be true for what? For both of them. So now, the questions, or the answers, I should say, in the middle here, are they a solution to both? No, they are not. They are not a solution to both. All right? But greater than 4. Are those a solution to both? Yes. All right. So the answer for the and statement would be, I'll get you. The solution for the and statement would be anything greater than what? 4. So you have to just remember that. All right, Pickens, do me a favor. I need another chair, please. All right. Yes.
So when you have one like this, you need like 2. Are those both the answer or is just the 4?
It depends on what the question was.
Okay.
If the question was and, the 4 to infinity would be the answer.
Okay.
If it was the or statement, it would be this.
So we should just write both of them?
No. All right? You make notes and say, if it was and, this would be the answer. If it was an or, this would be the answer. And if you don't want to do the and statement at all, you can just write the answer for or. Quickly.
So when you like divide or when you multiply a negative by negative, it has to change the sign.
That's right. Whenever you multiply, divide by a negative, you have to change the signs. Okay? So now, again, that's enough for that. All right? Please go now to the absolute value inequality review. Now, if you'll notice here, it's rather extensive. All right? And part of the reason why it's extensive is because this is a 2-day event. All right? So it's not really a big deal. All right? Part of it is a review, and then part of it is the new material. All right? One more chair, please. All right? Now, again, everybody in Miss Pliego's class has been invited to my classroom. All right? So you can get this, put it in Google Classroom or put it in Notability. All right. Now, from the earlier in the year, to solve an absolute value equality, you write it as 6b minus 3. You write 6b minus 3 equals 21. And then you write what? 6b minus 3 equals negative 21. That was the rule. All right, so for absolute value inequalities, there were 2 solutions because it could be either positive or it could be what?
Negative.
Or it could be negative. So because we're great at mental math now and we're practicing, all right, I'm adding 3 and dividing by 6, right? So B could be what? What? Add 3 and I get what? 24. And then divide by 6. 4. So B is equal to 4.
But it's negative, and if the 3 turns to a positive, you put negative.
So, some of you guys now listen. You're just not paying attention. You're just not listening. I don't care what you think. You're not. All right? All I said was to solve an absolute value equality. The first thing you do is you write what's inside the absolute value and you set it equal to 21. Then you do the same exact thing. You take 6b minus 3, 6b minus 3, and then you set it equal to what? Negative 21. Because the absolute value of 21 is 21, and the absolute value of negative 21 is 21. All right, so that's how you do it. Now, I'm expecting you to be able to do a 2-step equation in your head. So I'm adding 3, which makes it what?
Negative 18.
Okay. So I'm obviously not making myself clear. I'm right here on the first equation. I know what you thought. All right, but some people had some problems with the first equation. So I would add 3 and it becomes what? Then I would divide by 6. 4. Now over here, B would equal, add 3, divided by 6. Perfect. Those are my solutions. That's all you have to do. It's super easy. I'm agreeing. That's how I know you're not listening. All right, number 3, just to make sure, all right, just to make sure we're good, we're going to say negative 4 plus 8k equals 68, and then we're going to say negative 4 plus 8k equals negative 68. So 8k equals 72, so k equals 9. Anybody got any questions with that? No. And finally, 8k equals negative 64, so k equals negative 8.
not the first one because you're adding when you subtract it. What would you do?
On number 3? I added 4 to both sides, Jack. Shh. You see that, Jack?
Yeah.
What, Connor?
So basically, the only thing with the 2 lines is just you make one side positive and the other side negative.
Couldn't have summarized it better myself. That's it. All the math is easy if you listen. All of it. All right. Now, let me get a little crazy. Jump down to number 11. Now, the problem with number 11 is that the absolute value is not isolated. Just divide by 5. So everybody's going to write absolute value 9 minus p equals what first? 3. Then 9 minus p equals 3. 9 minus p equals negative 3. So now we have negative p equals negative 6. P equals 6. Negative p equals negative 12. P equals 12. Any questions? All right, let me find something that might be a little bit harder for us. Nothing. All right, nothing is hard. All right, so here we go. Now for the new lesson. Here we go, guys. The new lesson today is solve the absolute value inequality. Basically the same exact thing. No difference. That's why I wanted to review first. All right. So the first thing for number 15, we're going to write negative 9 plus 9m less than or equal to what? 27. Everybody recognize that, right? We write it without the absolute value, just the way you see it. Then, what do I do to the signs? Change them. Listen to what you just said. Change the signs. So what does that mean? Negative 9 plus 9m greater than or equal to negative 27. Don't look at me like I'm crazy, like you don't know what I'm doing. All right? We did an absolute value equality, and we set it equal to the positive, and then we set it equal to the what? Negative. The same thing is here. Nothing is different. The only thing you might be questioning is like, well, it was less than, now it's what? Now it's greater than. So why did I emphasize change the signs? Because when you multiply or divide by a negative, you do what? You change the signs. Right? So the rule for solving absolute value inequalities is you write it as if the absolute value signs were not there. Then you rewrite it, but you change the signs. Now, all you have to do is listen to me very carefully on that. Those are the rules. Those are the rules. All right? To solve an absolute value inequality, you write it exactly the way it is. Then you rewrite it with changing the signs. All right? Now, let's go ahead and knock this out and see what's good. All right? So I add 9. That would give me what? 36. Now I have to do what? So m is less than or equal to what? 4. Over here, 9m is greater than or equal to negative 18. So m is greater than or equal to negative 2. So if I'm less than or equal to 4, solid dot. And if I'm greater than or equal to negative 2, guess what less than is? Less than is an and statement, which probably means greater than is the or statement. All right? Now, in this case, right here, I would want you, if we write it using interval notation, we start at what?
-2.
And we end at,
4.
there you go. That's all there is. It really is that simple. Well, that simple. All right?
Wait, Mr. Snow.
I'm listening.
I thought that if it was like an open circle, it was that.
Well, aren't these, no, you just made a mistake. So listen, remember, let me explain to you again. Equal to means it's filled in. You with me? Equal to is filled in. All right, let's take a look now at 17. All right, so everybody should be able to write it out. Everybody should be able to write out the first step. The first step is negative 2x plus 8 is greater than 6. And then negative 2x plus 8 is what? Less than negative 6. That's all there is to it. Now you just have to be able to solve a two-step equation. All right? So I have negative 2x is greater than negative 2. So be careful. X is less than 1. X is less than 1. Again, multiplying and dividing by negative, change the inequality sign. All right, so next, I have negative 2x is less than negative 14. So x is
Greater than 7.
x is greater than 7. All right, so now we'll look less than 1, greater than 7. Brilliant. So this is an or statement. All right. So if you want to, you can just put or there, but it's not necessary. It can't be on both sides at the same time, so it's not an and. So now we're doing our interval notation, negative infinity to 1 union 7 infinity. Connor, you happy with that?
Yeah, everything is, I'm still hung up on the infinity sign.
Okay, so listen, let me show you what helped, I think, some of my kids. Watch. Over here is negative infinity. Do you understand that? And over here is what? Does that make sense? So I'm going from, watch, from here to here, and then I'm going from here to here. So I'm starting reading numbers from left to right.
Yeah.
So I'm starting from negative infinity and going to 1. Then I'm going from 7 to infinity.
How do you know when to go left to right?
I always go left to right when I read numbers. Always.
No, but the one is left and the second is right.
Okay, because here, look right here. This is the important part that'll answer all your questions. Less than 1. If I'm less than 1, I'm going to the left. Do you agree? If I'm greater than 7, I'm going where? Yes, sir. You good on that now? That's it. Come on, man. Stay with me. What?
Would you change like the greater than and less than because it's a negative?
Are you asking me from here to here?
Yeah.
Yes, we multiply, divide by negative, we change the signs. All right, let's take a look at 19 now. So again, not difficult. 2n plus 1 less than 17. 2n plus 1 greater than negative 17. So 2n is less than 16. N is less than 8. 2n is greater than negative 18. N is greater than, so let's find negative 9. Greater than, very good. Less than 8. So it's everything in between. That would be an and statement. So, reading from left to right, I would start with what? And I would end at, that's all it is. Connor? All right. Here we go. Trying to get a little crazy. We have to isolate, and we're dividing by a, so I have to, that's right. So the first thing is negative 2p minus 8 less than or equal to 28.
Yeah. Oh my gosh.
Everybody good with that?
Yes.
And now it's just a matter of writing it out. Negative 2p minus 8 less than or equal to 28. Negative 2p minus 8 is greater than or equal to negative 28. Any issues with that? Now, solving. Negative 2p is less than or equal to, so p is
Oh, and it's change the sign.
Greater than or equal to
negative 18. Everybody happy with that?
Trick us.
Then negative 2p is greater than or equal to, so p is less than or equal to 10. Okay?
Oh, wait, we have to.
So if I'm greater than negative 18, and less than or equal to 10, so that just means I'm everything in between, which means I'm from, bless you. Any issues?
I don't understand why it is p is greater than or less than negative. I mean, greater than or equal to negative 18.
Because I divided by negative, right?
Oh yeah. Okay.
All right, good question. Again, be real careful. That's where all the mistakes occur on all the standardized tests. They throw in negatives. All right, any questions with that? All right, let's see if there's something else harder. All right, let's knock out 25. All right, so the first thing I have to do is what? What's the first thing?
Change the sign.
You have to isolate the variable.
So I have to do what? You guys are not answering my question. What is hard? Add 1. What are you guys saying?
Oh,
Multiply, divide. I don't know what you're doing. Adding 1. You're isolating the absolute value. So the absolute value of 3 minus 2x is less than what?
15.
Less than 15. Everybody agreement with that? And so now what? 3 minus 2x is less than 15, and 3 minus 2x is greater than negative 15. Subtract 3. Divide by negative 2. Easy. Subtract 3. Divide by negative 2. Greater than negative 6, open circle. Less than 9, open circle. That's right. And from there, we say what? Any issues? Okay, so I'm pretty happy. I told you it's not that hard. All right, now what I want to do is we're going to review some of the compound inequalities. All right, we're trying to get better at understanding the number line. All right, which means I want you to use interval notation if you can. All right, if you don't like just going to interval notation, put it on the number line, and then sometimes the kids think putting number lines is easier to go there to interval notation. So first thing I have to do is what? So x is greater than or equal to 5, or x is, now I'm hoping now that you've been thinking about it for a couple days, so I'm hoping you can say, well, if I'm greater than 5 or less than -5, it goes in what? Opposite directions. Everybody with me on this? You should be able to start to visualize the numbers. I'm less than -5, greater than 5, so I'm in opposite directions. All right? Which means if I wanted to write this in interval notation, it would be hold on. I wrote this as a font. Thank you. And then bracket 5 to infinity. Now, yeah, there's a bracket. There are brackets on both of them, right? No, you said 5. That's why. So let's say for some strange reason you're not seeing it very well. It's not really a big deal to say this is -5. I'm less than or equal to. And then here's 5. I'm greater than or equal to. Now you can see it better. I go from -infinity to -5. Then I go from 5 to infinity. Very good? All right, so number 3 is going to be an and statement. So all I have to do is what? Yes? Divide by -2. So this becomes a 3. Then it's greater than or equal to now. N greater than or equal to what? -1. Now, if you write that, people will just know you're not, you have the answer, you know how to do it, but that's not the traditional way that we write it, because we write the what? Smaller number first. So then you would rewrite it as -1 and 3, switching the signs. Now, to me, that's easier to say that n is between -1 and 3. So we would just say bracket -1, 3. Go ahead. Good for you.
Why wouldn't it be -3? Because like you do.
Okay. So listen to me.
Divided by 2.
No. You're doing -6 divided by -2, buddy.
Oh, okay.
You're still switching the signs, but you're still dividing by a negative.
Okay.
Right? So negative divided by negative is positive. Positive divided by negative is negative. Yes, sir.
Divided by the wrong.
I got you. What?
Can you like write it out on the line? Because I don't feel when you read it right to left, you know what you're supposed to do?
Yes, but here's what I want you to tell me, James. Because you're smart enough to look at that and say n is between -1 and 3. That's what that means. Right? So if n is between -1 and 3, that means, pay attention, n is less than 3. Then you read it the other direction, n is greater than -1. You know what I mean? Right? But it's hard to think that way. All right, that's why I try to tell kids, make sure I don't say -1 is less than or equal to n, because that doesn't make sense, first of all. Right? It makes sense if you just say n is between -1 and 3. Are you guys telling me the bell's ringing? Is that what you're telling me? Okay. So again, homework, guys. I'm not really, it's a 2-day project. We're going to do the odds tonight and the evens tomorrow, and then we have no homework. Right? So the more you do tonight, the less you have to do tomorrow. All right? If you're really crammed, there's a whole bunch going on, we're just doing it tomorrow. All right? Yeah. Good job, guys. Good job.